I am Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. In case you want to learn from me, you can always send an email on the address given. We can start online classes as I am doing with many students globally. In this particular video, we'll learn about tilting. Now, when we talk about moments, I've seen students getting very confused about the concept of tilting. I'll actually take two examples, and with the help of these two examples, we will learn how to apply the concept of tilting to solve questions. The very first question is before you. Have a good look at it. And here is the second question. So these are the two questions which we are going to solve in this particular video. So let's begin with the very first question, which is about tilting. But before that, let's understand what really tilting is. When a rigid body is on the point of tilting about a pivot, the reaction at any other support is zero. That's what it means. So what I'm trying to say here is that let us say this is a rigid body which is supported at 2 points, and if it is at the point of tilting at C, it really means that this will tip over, right? And so there won't be any support here. In that case, the reaction here will be zero. That's what it means when we say the reaction at any other support is zero. Correct? Let's try to understand with the help of a simple example. A uniform beam AB of mass 40 kg has length of 14 meters. It rests horizontally on the support C and D as shown in the figure. When a child stands at A, beam is on the verge of tilting about C. Find the mass of the child. So that's the question for you. So we are saying that when a child stands at A, right? So let's say the child stands at A. In that case, there will be the mass of this child which is acting at A. Let's call this as M times gravity gives us the force in newtons. Now this will cause tilting at C. Tilting at C you can visualize like this. That means just on the verge, so I'll enlarge this a bit and show you how the rod will be when it kind of tilts, right? So when it kind of tilts, you can see here. So as you can see, what is happening here is that at D there is no support, and therefore the reaction at any other point, which in this case is D, is zero, right? So you get the idea, right? So that is what it is. So now when the child is at point A, it is on the verge of tilting. That means we are in a state which is kind of just leaving this point, right? So it is not tilted yet. However, it is kind of just above it, right? So we'll say that the tension here, which was existing, so TD is now zero. You get the idea. So that is what it is at the verge of tilting, or when it is just about to tilt, or sometimes we also use the word turn over. So we use tilt or also turn over. So turn over this particular point, then the tension here or the reaction here is zero. So when there is a support, we normally say it's a reaction. So we can say reaction at D is zero. So let me write R. Now, there's only one point at which the whole rod is being supported, And at this point, the clockwise and the counterclockwise moment should be equal. You get the idea. So at this point, the clockwise moment and the counterclockwise moment should be same. Now, the child here will produce a moment which is in this direction, which is counterclockwise, and the weight of the beam is causing a clockwise moment. So these should be exactly same at C. So to solve such questions, we have to check moments at C. Correct? And while doing so, we'll say that the reaction at D is 0 since it is on the verge of tilting. So that is the basic concept. Now, the question becomes extremely simple. So it says a uniform being AB of mass 40. So this mass of 40 is acting right at the center. Since the total length is 14 meters, it is 7 meters from this particular point, correct? So it is 7 meters from here, right? So this is midway. And the beam is at rest, supported by C and D. When the child stands at A, the beam is on the verge of tilting. Find the mass of the child. So let the mass of the child be M. In that case, the situation is that at A, we have a force of mg acting. Now we'll consider the moments at C. So if you consider moments at C, then because of the child, it will be mg, the weight of the child, times the distance, which is 4 meters. And this is clockwise. That should be equal to the counterclockwise, which is now due to the mass of the rod itself or the beam itself, which is 40 g, and the distance of this from C is how much? Well, total is 7, so this is 4 from here, so that distance is 3 meters. Correct? So it is 3 meters. So that gives you the equation to find the unknown mass of the child from the equation, as you can see very clearly. Correct? So from here, we get the mass m is basically equal to 40 times 3 divided by 4. G cancels, right? So both sides G cancels, and that's what we get. And this simplifies to, you can divide this by 10, and so we get mass of 30 kg, correct? So that is how we could do. So the answer here is mass of the child is 30 kg. Is that clear to you? So that is how such questions can be solved very easily. So you have to just take a moment about the point which is the point of tilting, right? Do you see the pivot point, right? So let's take the second example to further elaborate on this particular concept. So example number 2 here is a uniform beam AB has a length of 10 meters and weight 15 newtons. It is in equilibrium, resting horizontally on the supports of C and D, where AC is 1.2 meters as mentioned here and DB is 2 meters as mentioned here. A boy 30 kg stands on the beam at a point E. So this is important to understand. A boy 30 kg stands on the beam at point E. The plank or the beam is about to tilt at D. So now tilting point is at D, right? By modeling the boy as a particle, calculate the distance AE. So since we're talking about D as the point of tilting, where should the point E be? So that is a major question which needs to be answered. So here we have to figure out where should be the point E, right? That is very critical to figure out. So if you figure this out, then the question becomes very simple. Now, what is the concept behind this? Because while teaching my students, what I have noticed is that this is the real questions to be answered. If they understand where to take this point E, then they can very easily solve the question. Now, since it is tilting about D, we should not be taking E on this side because then it will tilt on C, correct? If I am taking E here, then it will tilt on C first, not on D. And that means E could be in between also. If I take E in between, let us say if I take E somewhere here, in that case, what happens? Well, the system is in equilibrium, right? And in between, we are taking E. It is not going to tilt on D. You get the idea, right? Because there is a support on this side, and so it is very difficult to tilt. However, if I take E here, in that case, the beam can easily tilt about D. You get the idea. So, therefore, the child has to be somewhere between D and B. Is that correct? So, somewhere here will be our point E. So, weight of the child will be now placed here, correct? Now, which is, we are saying we are given the weight 30 kg, right? So, 30 kg, a boy, a 30 kg stands on this beam, and so this is 30 g. Now it becomes easy. We have to model this as a particle and the distance A to E we have to find. So we have to find the distance from A to E, right? This is what we need to find. Correct. So let me take X as a distance. I'll keep it very simple. I will take X as a distance between D to E. So I say let X be distance DE, right? Is that clear to you? So I'm taking x as distance d to e, and I know very clearly that from a to e it will be how much, right? So ae will basically be equal to x plus a to d, right? Which is simpler to calculate. So x plus a to d is basically 2 less than the total length of 10 meters, right? So it is 8 meters. You get the idea. So this distance is basically 8 meters. So what I will do here is I will calculate this x and add this to 8 meters rather than taking x from a to e and making the equation very complicated. So this is first step, and that is to have simple solution. You get the idea, right? So we'll really have a very simple solution here. So first you understand where the point is, and now you also understand what distance should I take as my variable. So this makes more sense. Now if that is the case, now take moments about point D, right? Since it is tilting, so this reaction at C is 0, right? So reaction at C is 0. Clear? So the only moments which are acting at D are one because of the weight of the rod, and this is in the direction of, as you can see here, counterclockwise, and the other because of the boy, it is in the direction of clockwise, and they should be equal. Perfect. So that is what we have to equate. So 15 into the distance from center to D. Now the total length is 10 meters, and this is 2 meters, and therefore from 5 to 5, this is 5 minus 2, this is 3 units, correct? So 3 plus 2 is 5. And so this is 5 meters. And on the right side, we have 30. Let me just make more room here. So we have 15, which is the weight in the center. It is already given in newtons, and the distance is 3 meters. That should be equal to 30g times the distance which is unknown, and that is x for us. So we can find what x is. So from here, x is equals to 15 times 3 divided by 30g, correct? So let's use the calculator to find this particular value. So it is 15 times 3 divided by 30 divided by 9.81, and what we get here is 0.152. So we get this as 0.152 from D. So total distance will be, A to E distance will be now equal to 0.152 plus 8, and that is 8.152, or you can say approximately 8.15 meters. Does make sense to you? So that is how we can actually solve this particular question. So I hope you have understood the strategy which we have used to solve this particular question, right? So it is kind of messy. So let me just take you to, once again, provide you with some calculations in a fresh page so that you understand what we really did. So we selected point E between D to B, and we took this distance as x, and then we found the moments at point D. Do you see that? Now moments at point D, from this diagram it is very clear. Since this is the center point, so this is center, that means total length was 10, so this total is 5, correct? 2 already there, that means this distance is 3. And therefore, when we are talking about moment due to the weight of this being, so the counterclockwise moment, which is in this particular direction, counterclockwise moment is basically 15 into 3, correct? And that should be equal to the clockwise moment because of the boy standing here, right? The distance being x, and the mass is given to us as 30. So mass of 30 has to be multiplied by g. So we have 30g, and the distance is chosen as x. So from here we find the value of x. So x is equals to 15 times 3 over 30g, right? So that is the value of x. Now the question was saying that calculate the distance AE, right? So we wanted to calculate the distance A to E, that is from A to this particular point. And we can easily add, we can actually subtract to this distance here is 2, total length is 10. So 8 is all this distance from A to this particular point, correct? Avoid these decimals. You could always add them to get this idea, but 8 and 2 is 10. So the total length A to E will be equals to 8 plus x, and that is how we found our answer, which was 8 plus 0.152 meters. Is that clear to you? Or you can say 8.152, or we can just write 15 meters is the distance from A of the boy standing. Is that clear to you? So I hope this makes sense. And the critical point which we have understood is the position where the boy should stand. And once it tilts about D, the reaction at C is 0, right? So this reaction here is 0. So we are only looking into two moments, one due to the weight of the beam and the other due to the weight of the boy. Perfect? So I hope that makes sense. Now, I'll recommend you to watch my video with my student Amy, where we are discussing questions from her book, and we have included two questions from past Edexcel test papers. They will help you to understand how we should solve difficult questions. I hope it makes sense. Feel free to write your comments, share your views, and if you want to learn from me, you can send an email on the address given. Check our website for the latest updates. Thank you and all the best.